video is on limiting and excess reagents, and it's probably the hardest video so far in the course. So what I want you to do is know that going into it, take some time, you might need to watch it more than once, and be patient with yourself. You may not get these right off the bat, but that just means you might need to practice some more at this, and I will give you lots of practice questions in class. So don't be shy saying that you don't get this. It is tough. Be patient with yourself and try your best not to get frustrated. So, limiting and excess reagents, first thing we're going to do is define what these are, and then I'm going to talk you through some examples. So, we've looked at stoichiometric quantities before. These are the molar quantities of reagents which, when reacted together, are completely consumed or used up. So these are the quantities that we get from the balanced chemical equation, and we use the mole ratio when we're looking at these types of problems. Your limiting reagent is a reactant that is completely consumed or used up in a reaction. And therefore, because of that, it will determine the maximum amount of product that can be formed. The reagent in excess, some of this reactant is actually left over at the end of the reaction. So I've got a diagram here to sort of show you what this is. So let's pretend I've got these triangles and these squares reacting together. If you look at the start right here, I've got 4 triangles and 1 square. And when it reacts, here's my product here that I want to make, and I have some triangles left over. So if I go back to my definitions, my triangles that are left over here, that's what's going to be the excess reagent. So remember how I said some of this reactant is left over? There it is right there, left over. In this case, my square is going to be my limiting reagent. We often just say LR because that one is completely consumed. I don't have any of it left over at the end of my reaction. It's all used up and bonded in with my triangle. Here's another picture. If you want to have it, another look at it again, I've got green dots and red dots to start, and my final product is this green and red sort of combination there, but you can see all the red dots got used up, all 6 red dots got used up, but I ended up with 2 sort of leftover green little molecules or dots or whatever you want to call them. So my green in this case is my excess reagent, or ER, and my red is my limiting reagent, LR. So hopefully that makes sense. So now what we have to do is use stoichiometric quantities and actual numbers to calculate what is a limiting reagent and which is going to be your reagent in excess. So here are your steps. For those of you that like to memorize steps, you've got 2 types of questions here: to determine the limiting reagent and to determine the amount of excess reagent. So to determine the limiting reagent, first step, number 1, determine the number of moles of each reagent. That is different and totally new than anything we've ever done before. Then what you're going to do is you're going to calculate the number of moles of any product expected, again, from each reagent. This means that you might have to do this step 2 or 3 times. So if I've got 3 reactants, I'm going to have to do this step 3 times. If I've got 2 reactants, I'm going to have to do this step 2 times. If I've got 8 reactants, I'm going to have to do this step 8 times, but I probably won't give you one that's that hard because that's really mean and a lot of work. And then number 3, the one that produces the least amount of product, is the limiting reagent. The others are in excess. And then if you're going to determine the amount of excess reagent, so how much is left over at the end of the reaction, you subtract the amount in moles. Again, make sure your units are consistent, so you have to find moles, and you're going to subtract the amount that's used up in the reaction from the original amount of your excess reagent. And again, you might have to do some stoichiometry for this, so I'm going to talk you through an example of that. All right, well, let's go and do an example then. So, how much HCl is produced? I would want you, before we get started on this question, to realize that in this case, I'm giving you 4.50 grams of hydrogen and 140 grams of chlorine gas. I'm giving you data for 2 different reactants. Every other question we've done up to now, every other problem, I've only ever given you data on 1. So I would give you, oh, you've got 4.5 grams of hydrogen. How much HCl will you make? Okay. The difference now is that you actually have 2 different numbers. That means that you have to figure out which one is excess and which one is limiting, because the one that's limiting is going to tell you how much of your product you actually make. So if we look back, step 1 says determine the number of moles of each reagent. So that's what I'm going to do. I'm actually going to divide my screen into 2. Okay, I'm going to have the number of moles of H2 on one side and the number of moles of Cl2 on the other side. Okay, so that's my first step. I'm determining the moles of each reagent. So H2, what have I got? I've got 4.5 grams to start. How many moles is that? So I multiply that by 1 mole divided by the molar mass of H2, which is 2.02 grams. So when I do that, and you should be doing this along with me if you're writing down your notes, 2.227722, etc. moles of H2 gas. For my mass of my moles to mass to moles of chlorine, to find the moles of chlorine, that's my second reagent, I'm going to do that over here. So I start off with 140 grams of Cl2, and again, I'm going to end up dividing by your molar mass. So I'm going through this step quite quickly because I think that converting from mass to moles and moles to mass is pretty easy right now. If it's not easy for you, that's okay. It just means you need a little bit more practice. And if you need more questions, you can come see me. So if I do 140 divided by 70.9, again, that's my molar mass of Cl2, right? So I have to take 2 chlorines and add them up. I do that and I get 1.97946 moles of Cl2. Done. Great. So that's my first step. So I have done number 1, determine the moles of each reagent. Check. Now I have to calculate the number of moles of any product, so in this case it's going to be HCl, expected from each reagent. So I have 2 reagents. I have 2 moles that I've already calculated. That means I'm going to have to calculate this 2 times. So let's do that now. So I'm going to find the number of moles of HCl from my H2. And I'm going to find the number of moles of HCl from Cl2. So let's start with the H2. We'll work with one side at a time. So my number of moles of HCl from my reaction, again, I'm going to write down my calculation, my answer from my previous calculation, so 2.227722 moles of H2. And I'm going to use now my molar ratio to figure out how many moles of HCl I have. So that's moles of HCl, that's what's going to go on the top. Moles of H2 I want to cancel, that goes on the bottom. And where do I get my numbers from? Remember, I get them from my balanced chemical equation. So in this case, I've got a 2 on top and a 1 on bottom. So when I do that, I can calculate that I get 4.45544 moles of HCl. Now, what does this mean? Write this sentence down if it will help you. This means that, how do I say this? If I have 4.50 grams of H2, that amount of H2, it can make 4.45544 moles of HCl. So if I start off with 4.5 grams of H2, it can make this many moles of HCl. That's what that means. So let's leave that for now and find out how many moles of HCl I can make with my chlorine gas. So in this case, I've got 1.97946 moles of Cl2. And again, I use my mole ratio. Moles of Cl2 I want to cancel. That goes on the bottom. Cl2. And moles of HCl over here I want to keep. So I put that on top of HCl. Oh, I'm running out of room. And again, my numbers I get from my balanced chemical equation. So if I look up here again, I've got 2 HCl's for every 1 Cl2. So I put a 2 on my HCl and a 1 paired up with my Cl2. So I take my answer, times it by 2. I'm just going to clean this up a little bit. And I get 3.95892 moles of HCl. So this number means, it's a separate calculation, if I have 140 grams of Cl2, it can make, or I can make, however you want to word it, 3.95892 moles of HCl. So now I can compare apples to apples, or I can compare two numbers that have the same unit. That's what I want to be able to do, because if I don't have the same unit, I can't really compare the two. So I've got moles of HCl on one side, moles of HCl on the other side. Now I can compare and figure out which is going to make the least amount of product. Okay, so the one that makes the least amount of product is your limiting reagent, and the others are in excess. So if I go back here, the one that made the least amount of product is this one over here. This is my limiting reagent, made the least amount, so therefore chlorine is my limiting reagent, and Cl2 is my excess, or sorry, yeah, chlorine is my limiting reagent, and H2 is my excess reagent. All right. So how much excess reagent is left over now? So this is where we have to, if I go back, to calculate the excess reagents down at the bottom, you're going to subtract the amount in moles used up in the reaction. So, oops, there we go. So if I look, I'm going to use up 3.95892 moles of chlorine, and that means I'm also going to use the same amount of H2. So, to start off with, I know that I'm going to have 3.95892 moles of HCl produced. Okay, and I started off with, sorry, I'm just recopying my number here. I have 4.45544 moles of HCl from my hydrogen. Okay, I should probably write that on opposite sides of the board just so that you guys don't get too mixed up with that. Okay, so to do your excess reagent, we have to subtract the two and then possibly convert it back. So there's a couple of different ways you can do it. You can subtract the moles of H2 that you start with minus the moles of H2 that are used up. And that will give you the moles of your excess. So in this case, the moles of H2 that's used up is going to be this number here, divided by 2. And the moles that I start with is going to be that, divided by 2. So let me just talk you back for a second, if that's not super obvious to you right off the bat. I'll use blue. This number here is how many moles of HCl I could have used up. This mole here, that's how many moles of H2 I start with, given the fact that I started with 4.50 grams. So let's recopy that number over here. So that's 2.227722 moles of H2. That's what I started with. Now I'm going to subtract it from the moles of H2 that got used up. Oops, I went backwards. There we go. So the moles of H2 that gets used up is going to be this number over here. And the reason why that is because the H2 and the Cl2 are in a 1-to-1 ratio. So in this case, it's my 1.97 ... I didn't get the number down. 1.97946. 946 moles of H2. So when I subtract those two, I end up with 0.248262 moles of H2 that is left over. Okay, so usually you could leave it like that. I haven't specified in the question that you need to convert it to grams, but the last step would be to convert it to grams. So to find the number of grams of excess H2 would be 0.248262 moles times by, in this case, the molar mass of hydrogen. So 0.01 grams of H2. So I started off with 4.5 grams of H2. I'm using about 4 grams of my H2, and I'm going to have 0.501 grams of H2 left over. So that's how you do limiting and excess reagents problems. We will do more as I check your understanding and more worksheets as we go through. And that should be it.